Hello and welcome to checkpoint 3.10. In this checkpoint, they want us to find the arc length function for the helix. So helices, remember, are the nice functions where we can find the reparameterize it so that it's parameterized by arc length. And parameterized by arc length, if you remember, is a way we parameterize things so that if our parameter goes from 0 to 1, we'll have an arc length of 1. Or if your parameter goes from 0 to 5, you'll have an arc length of 5. Okay, what we're going to do is use the formula for arc length. And we usually call the formula S as a result, but this time we're going to leave S as a variable, and we're going to set it equal to the arc length formula as a variable. And so we'll see that the upper limit here is going to be t, which means when we integrate, we're going to need to use a different variable aside from t. Usually we use t here, but since we're using t as a parameter, as an upper limit of an integral, you can't use t for your dummy variable in an integrand. And we can call this whatever we want. And call it a or alpha or u or star or whatever. So we'll just call it this. And we're going from positive values of 0 to infinity, so we'll just go from 0 to t. Okay, we need to find r prime. R prime of t is going to be the derivative cosine is negative sine, negative 3 sine t, positive 3 cosine t, and then 4. And if we want the magnitude of that, this is going to give us a square root of 3 sine t quantity squared plus 3 cosine t quantity squared plus 4 squared. So we have a sine and a cosine, sine squared and cosine squared with a factor of 9, and we have 16. And so this is 25, I believe, and so we get a constant. So that's the real nice thing about helices and circles, in that their magnitude is usually constant. Circular helices and circles. So now that we have a constant in there, let's use the formula. And we'll have S is equal to the integral from 0 to t of 5 dt. That simply is equal to, oops, this is du, remember, we're using the dummy variable u. There are no variables. We have a constant, again, because it's a helix or a circle, then this makes a nice, easy thing to deal with. So this is going to be 5u. We'll evaluate that from 0 to t, so that's just going to be 5t. And S is equal to 5t. And so what we want to do is we want to replace the t's that we had in our original parameterization and replace it with an s. And that's usually the variable that we use when we parameterize by arc length. So we're going to reparameterize this. We'll say within this equation, if we solve for t, t is equal to s, or 1/5 times s. So we're literally going to take this and replace it with t in our original parameterization. So therefore our new parameterization, parameterization by arc length, we say, is going to be a new r, and this time we'll use the parameter s, and like I had mentioned, we'll have a 3 cosine, and then wherever we see a t, we'll replace it with this new parameter, not just s, but 1/5 times s. And then we have 3 sine, again, 1/5 times s, and then we have a 4 times 1/5 times s. Okay, so that is your new parameterization. And if we take this and do things like find the arc length from 0 to 2, then your arc length is going to be 2. Or if you take the arc length from 0 to 7, then your arc length is going to be 7. So that's what it means to parameterize by arc length. Okay, I hope that helps.